Hi everybody, do you remember that yesterday we talked about a few different properties of sound, and that sound also we talk about intensity as being, what did we talk about? We talked about intensity being how the volume of something and the loudness of it. And so we also showed a couple of different formulas that we can use. And so we're going to practice some of that right now. And I have a worksheet for you that I'm going to be sending out to you. But the worksheet, you can choose whether you're going to print it or not, or if you're just going to look at it offline and then do the problems on there, and then I'll ask you to insert them into a Google form. So I'm even going to give you some free answers here. So, well, wish me luck with this pen. It's new and it doesn't work too well. Okay, so what is the intensity of sound waves produced by a trumpet at a distance of 3.2 meters. Now this is important. That's the radius, because remember I said that these are all boy, that's a terrible circle. So sound travels in concentric circles, and so they keep on going out and out. And remember, it is spherical, not just two-dimensional, but for this purpose it works quite well. But anyway, so however far you are from it, that's really the radius that you're looking at. Okay, and then when the power output from the trumpet is this many watts. Okay, and so assume that the sound waves are spherical and longitudinal waves. We're going to assume that for every single one of them, and that they spiral outwards, and that there isn't any type of blockage from any side of it. So what we're going to do is we're going to find the intensity of this one. So the intensity, again, equals the power. Okay, and the power here is 0.20 watts. Okay, and then that is all over 4 pi. And then radius, again, was a 3.2. And we've got to square that. Okay, and I forgot to write that this is in meters, so meters will be squared, so our unit will be watts per meter squared. Okay, so let's go ahead and take a moment. Make sure that you are able to calculate that yourself. I do the order of operations, so I'll do this part first. But go ahead and calculate this, and I will give you the answer as soon as we return. So this answer is 0.00155, and we usually write these in scientific notation. There is only 2 sig figs here and 2 sig figs there, so it's 0.6 times 10 to the, let's see, 1, 2, 3. Okay, and that is going to be watts per square meter. Okay, let's look at another one. Okay, calculate the intensity of sound waves from electric guitar amplifier, okay, at a distance of 5 meters. Okay, so that's our radius again. Put a little R there if I can do that. When its power output is equal to each of the following values. So this is 3 different problems. They want you to figure out the power output. I mean, it makes sense that this second one would be twice as much, but let's go and double check that. So I equals power over 4 pi r squared. Okay, I scooched that up there a little bit better. Anyway, so let's go ahead and figure out our intensity. We know that our power is going to be 0.25 this time. Next time will be that one, and then the third try. So you're doing 3 different problems here again. Anyway, so it's 0.25. Okay, and we know that it's over 4 pi. And then radius squared, I'm going to go ahead and square that 5. So it's 5 squared is 25. And then we have our square meters. Okay. See if I can get this thing to click off of there. There we go. Anyway, so go ahead and calculate that. Deposit here and we'll calculate it. Okay, when I did this, I got a 0.000795. Okay, hopefully you got the same thing. We like to have this always in scientific notation. So, and we have to also round this up because we do have 2 sig figs here and 2 sig figs over there. So we need to have this be 0.00070, excuse me, 80. So we'll go ahead and write that as 8.0 times 10 to the negative 4. And again, this is watts per meter squared. Okay. Let's go ahead and try this next one. Now it makes sense to me, since nothing is squared with the power here, that this is just going to be doubled. Okay, but let's go ahead and check it out and see if our math proves that too. So again, we're going to solve for intensity. We've got the power over 4 pi r squared. Okay, And so now we know our power is going to be, our power is going to, we're going to be adding a whole lot more power to the system. So that's just like turning the, turning in more electricity. So it's going to add more electricity to it. So it's going to make that speaker move more, or whatever else is creating that with this amplifier. And so if you put more electricity into it, it makes sense it's going to get louder. So we'll see how much. So we're going to do 0.50 watts, okay, for this problem, okay, and we've got to do 4 pi again, and that is going to be times the 5 squared again, okay, and I'm going to go ahead and square it now, and meters squared, and there we go. So calculate that. You do find that it doubles, okay, so you got 1.6 now, but now we've moved the decimal over also, so it's times 10 to the negative third power. Okay, well, this is A, this one's B, and you can complete C. You got an idea of where it's going to be at because of the power is now going to be how much more than this one. So you got an idea, so you can see how well you're doing on these. Now notice that they're in scientific notation, and so when we put them into the Google form, we'll have to make sure and be careful with that. When you go and insert into the Google form, I'll expect you to write is 1.6 times 10, and then you do a caret, and then you have a -3, and then W/M2, and that's going to be a big 2 because you can't do any kind of exponents with the Google Forms, okay? Okay, so with the next problems, this one here is solving for intensity again, and now you're given intensity, and you are also given the distance, so that's your radius, and they want to know how much sound power comes out. So this one you're solving for watts, okay, and if you remember right from our formulas from yesterday, we had finding the power. Power is the watts, right? And so you'll be using this formula right here to solve that one. Okay, I don't know why I keep this page here. Let's get rid of it. Okay, then let's look at the next problem. I feel odd because I'm not at home with you like I would be in the classroom. So if you want to go ahead and do the worksheet right now and not listen to me talk about a couple of them, that's fine. But I feel like I need to share some information on this. So I'm sorry if I'm talking down to you. How much power is radiated? Okay, so we're looking for power again. Okay, so we were given the intensity, and you're also given the distance, so you're looking for the power again. I should have wrote this different. You're looking for watts, which is power equals. So you're looking for power in both of those. And it's kind of nice for that one because really it's intensity and it is times 4 pi r squared. That's pretty nice for both of those. Okay, now moving on to the next problems. The next one, the maximum level of loudness. The power output is 75-piece orchestra radiated at sound for 70 watts. Notice the 3 sig figs there. Don't go by this 2 sig fig, go by 3 sig figs. So that right there is your power. Okay, what is the intensity? So we're looking for intensity, okay, when you're sitting this far from the orchestra. So that is your radius. Okay. Okay, and number 5 is your last one. The power output from a tuba is 0.35 watts. Okay, so that's your power. Well, what distance? Oh, now we're looking for radius. Okay, and here is your intensity. So, do you remember that radius equals the square root? And now this is where we're going to run to problems. Power over 4 pi times intensity. You have to be careful here because you have to figure out this whole fraction before you take the square root of it. Okay, so maybe you need to put it like this inside of your calculator so you don't goof up there. Okay, I will give you a hint on that one when you're doing it, that it is less than 5 meters. Okay, so go ahead and work on this worksheet. I do want to tell you though that we have been I've been noticing in all my classes that we probably should be taking short quizzes. instead of large unit tests. With the distance learning, I think that it is more spread out, and so I think that we'll forget for more information. So we've been talking about several things from constructive and destructive interference, how that creates standing waves, how that we then got into sound then after that, okay, and then these different properties of sound. We talked about how yeah, that's where we're at. So we're going to have a quiz like early next week with the different sound properties. What was it? It was, here we've got compression and rarefaction. So these are longitudinal waves, okay, and that the closer that they are, the higher the pitch is, the frequency. Notice that frequency and pitch are related. Here's a scientific way that we talk about it, and this is how high-pitched is perceived. Okay. We also talked about sound, how fast it moves through different mediums. We talked a little bit about Doppler effect. You were supposed to go and check out more. I can't wait to read your responses on that. Okay, now we've been talking about intensity, and then we even coupled that with the frequency to talk about the human speech area. Now, if you even want to go and look at online, there are some examples where you can hear the frequency from very low pitch to high pitch. Let me tell you right now that when you get over here, it's starting to become really high pitched and it's hard to hear. So if you watch one of those on YouTube, make sure you turn your volume way, way, way down, because this just all of a sudden gets high. And my ears already hurt at this area here. Okay, so be aware and be careful if you ever go and check those things out. Also, I want to say one more thing about intensity. We talked about decibels just so briefly, but I wanted to tell you about right here, 100 decibels. Now, earbuds used to be very, very popular, and they still are. In the European area, they will not let them go any higher than this. In the United States, they let them go up to 120 decibels. So it is dangerous. It is dangerous to have that close to your eardrum, that loud for a very long period of time. Now that I'm older, I hope that you heed my advice, because you know how deaf I'm starting to get in the class where I have to ask people to repeat themselves a lot. It's from loud music. Okay, so I just thought that I'd give my motherly little lecture there about that. Now we'll be talking about resonance and then a review on Monday. Okay? Well, I will talk to you later. Bye-bye.